Greetings, welcome back to a video lecture series on computer architecture. My name is Dr. Prashant Bachanna. In this video, we shall be learning the module 3 of the computer architecture. So, we'll be talking about the two topics, that is instruction cycle and data representation. So, how the CPU is designed. So, in the design of the CPU, instruction cycle, how the instructions are executed, and data representation plays a very important role. So we'll see these things one by one. So what do we mean by an instruction? So a program consists of set of instructions. So an instruction is written to complete a particular task. So each program has a sequence of instructions here. So which will do some particular components. So the basic computer system, each instruction is subdivided into the 4 pages. So whenever we say like any instruction is executed or any task is executed in the computer, so that will be in the 4 steps, that is fetch, decode, then the third one is the read the effective address from the memory if the instruction has an indirect address. So this third step is not necessary. So if it is an indirect address, then only the third step will come into the picture, and the last step is executed. So we can say that there are 3 steps of executing an instruction, that is fetch, decode, and execute. Okay, so we'll see these things one by one. So when we say like when an instruction is executed in the computer system, the steps will be fetch, decode, and instruction. Fetch, decode, and execute, and the third step will come into the picture if the effective address from the memory has an indirect address. So this is how this figure shows the same thing. That is, it will initiate the CPU will initiate the instruction cycle execution. So first the instruction will be fetched from the memory. The instruction will be fetched from the memory. Then it will be decoded. So decoded in the sense, the function of the decoder is to decode what operation to be performed. Whether the computer system wants to do an addition operation, subtraction operation, or an AND operation, odd operation, or read or write. So this decoder will execute, will decode what instruction to be executed. Then the third step, what we have already seen, if it is an indirect address, so that address will be read, and the final step will be execute. So we can say this is a cycle, instruction cycle, wherein it mainly 3 steps, that is fetch, decode, and execute. And if it is an indirect address, then the address will be read. So we can say fetch, decode, read address, and execute are the 4 steps of an executing an instruction cycle. So we'll see this these things one by one. So fetch and decode. So first the instruction will be fetched from the memory, then the decoder will decode it. So decode. So we can so here we use some set of registers here. So the program counter, all of you know, the program counter holds the address of the next instruction to be executed. So here S0, S1, S2. We made let's say example 0, 1, 0. Then the time cycle of T0 is equals to 1. So the program counter value will be loaded into the address register at the time period of T0. So at T0 time cycle, so first so with the help of the register, so we have to remember here. So whatever the instruction cycle or instructions are executed, these steps fetch, decode, and execute. So all these things are performed with the help of the registers here. So here program counter is a register which holds the address of the next instruction. So then the content of this program register is moved to the address register wherein it will have the address. So this is at the time cycle T0. So at the time cycle T1 and the next cycle, what will happen is the program counter will be incremented by 1 here. So here the T1 will be 1. So here again M address. So here the address register is stored in some memory location. So the meaning of this M bracket AR, it means, so this is our memory. So in the memory at particular location, so this address register will be stored. That is the meaning. So the address register which is stored in some particular memory location is moved into the instruction register. So what is instruction register? So instruction register holds the instruction to be executed. Okay, so the instruction register here, IR means instruction register which holds the instruction to be executed. So at a time cycle, instruction to be executed. So these two steps are fetch instruction. So the instruction will be, so these two steps will indicate with the help of the registers, the instructions will be fetched here. Then what is the next step of the executing an instruction? So the next step of execution instruction is a decode here. So what do you mean by decode here? So the decode is, decoder will do this decode, that is what operation to be performed. Okay, so what operation to be performed. So it will decode it. So that is also be done, is written in the computer system with the help of the decoder. So it's a 16-bit register here. So from the decoder, like the instruction register will have the bits from 12 to 14. Then the instruction register is at 15, which is moved into the instruction register, and the complete decoder value is moved from D0 to D7. So this is, so in this the time cycle T2, the time cycle T2 decode operation is done. So in the 4 steps we have seen fetch and decode. So with the help of these registers. So decode in the sense, so what operation to be performed, whether the CPU, whether the computer system processor wants to execute an addition operation or subtraction or AND operation or read or write shift operation. So this will decode what operation to be performed. It will tell the processor what operation to be performed. So this is how the instruction cycle, the different types of registers which are shown here. So this is our memory register. So the first step in executing instruction is the fetch, right? So fetch in the sense, the instruction will be fetched from the memory unit. So if it is a read operation, so it will be read at the time cycle of T0 and T1. So the time of T0, it will be, the instruction will be fetched. At T1, it will be decoded. So there are different buses are there, S0, S1, S2. Based on this, the instructions will be like with the help of the address register. In the address register, address is stored. So the program counter, it holds the instruction. It holds the address of the next instruction to be executed. Okay, then as soon as the instruction is executed, the program counter will be incremented by 1. So each time the function of the program counter is to give the instruction to be executed, and it will increment each time by 1. So and in the instruction register, instruction will be there. So that instruction will be loaded, and with the help of the common bus, the instructions, the addresses will be sent, and the instructions will be held. So all these things are happening at different clock cycles. Okay, this is how the representation is shown in the diagram. So whatever we have seen in this diagram here, that is, this shows the transfer of first 2 statements, that is fetch and decode at the time of T1 is equal to 1. So the program counter is moved into by making the selection inputs of 0, 1, 0 here. So here these things will be 0, 1, 0 at the time the read operation is done. So at T1 time cycle, it will be like 1 by 1, these values be 1, 1, 1. So at this diagram, the instruction will be decoded. So determining the type of instruction. So after executing the time signal T1, so after a fetch and decode, so the control unit here determines the type of instruction, that is read, that is read from the memory. So once the instruction is read and decoded, so it will the control unit determines the which type of the instructions. Let us say if D7 is equals to 1, the instruction must be register reference or input output type. So which kind of register it is, whether the instruction is in the input output type or register reference. Or if D7 is equals to 1, so the operation must be one of the other 7 values, that is from 0, 0 to 7, that is 0 to 6 here. So based on the value of D0 to D7, so it will determine the type of the instruction, that is the memory has, it has come from the memory. So the symbolic representation of the same thing is mentioned here. So here, like let us say D7, that is this indicates that the address register is there in the memory, okay, which will have an address register. So in the address register, address will be there. See here, nothing. Then in the T3 cycle, execute the register reference instruction here. Then at the same cycle, D7, D3, it will execute the input output instruction. So in the instruction type instruction, what we'll do is that based on the value of D0, that is from 0 to 7, so we'll determine which type of instruction it is, whether it is a register reference instruction or input output or the other instructions. So this flow diagram will complete tell the execution of 3 steps. In the previous diagram, we have seen only the fetch and decode. So the first part here is this is the fetch. So these 3 steps will fetch. These 3 steps will represent the fetch. As just so the start, the program counter will value will be moved to the address register. Then the address register, which is stored in the memory, will be moved to the instruction register, and the program counter will be incremented by 1. So here we have to remember, program counter holds the address of the next instruction to be executed, and after that, each and every time, it will the program counter value will be incremented by 1. So this is our first step of execution, fetch. Then the second step is the decode, right? So the decode instruction is written. So here all these fetch, decode, and instructions, execute instructions are written. The instructions are written in the standard format with the help of the registers here. So already we have seen this decode part. That is, it is a 16-bit register IR. So from 0 to 11, the instruction register value will be moved to the address register. So if the D7 value is 1, so it shows that it is a register instruction. Then if D7 value is 1, it's a register or IO kind of operation. That is the type of operation. Then if it is 0, so that the value will be from 0 to the 6 here. So by identifying the different type of so if the direct is so the next step is an address. So if the address is direct, the instruction will be directly executed. So if the address is an indirect address, then that indirect address will be taken from memory to the address register. So this part is called as the third step, that is loading the memory. Okay, so if it is having an indirect address, then it will be taken and it will be executed. So if it's a direct address, so it will be taken and the execution of the instruction will be done here. So here again, like in the from 0 to 6 value, as you have seen, it will identify which type of instruction it is being executed at different clock cycles. So execute, let us say if it is if it is 1, it will execute, it will identify the instruction type is input output instruction. Then if it is a register reference instruction, if it is equal to 1, that is the register value is 1. So this is the execution part. Okay, so this complete part, so this diagram, this complete part will show the 4 steps of execution, that is fetch, decode, loading the memory, and execute. So this is a flowchart for the execution of an instruction cycle, wherein we use different kinds of registers like address register, program counter, then instruction register. So with the help of these registers, the instruction cycle is being instructions are written and it will be executed. So now we have seen in the previous section here determining the type of instruction. So in the second step of the thing, it will determine which type of instruction it is, right? So there are different types of instructions here. So first we will see what are like register reference instructions. So if D7 is equals to 1, already we have seen, and I is equal to 0, so the instruction is recognized as a register reference instruction. Means the value will be stored in some particular register here. So the register reference instruction bits will be from 0 to 11, and the instruction code to be specified is by the 12 instruction. So these are the different 11 different register reference instructions here. So the first one is the CLA, that is clear accumulator. So if you write, so the mnemonic for this one is, if you write AC like 0 arrow mark toward this one, so this will represent clear accumulator. Then 0 is loaded into E, means clear E, right? Then CMA, so this will move the content of AC accumulated into the accumulator. Then so these are some different registers here. Then this is circular write shift here. This instruction will represent the circular write instruction, that is SHR accumulator. So the content of the accumulator is moved by write by 1 and the value will be moved. So this will do the circular write operation, and this instruction will do the circular left operation. That is, if you write SHLAC. So this is a mnemonic, the standard mnemonic here. SHL SHLAC means this will move the content of the accumulator by left shift by 1. So that is, then the next instruction is increment A. So if you write AC arrow mark AC plus means the program counter value will be this accumulator value will be incremented by 1. Okay, so these are some other instruction types here. That is halt. So like if S is start means the instruction cycle will be halted. So these are some of the register reference instructions here. That is 0 to 11. So these are 11 register reference instructions which are available in the computer system. Then apart from register reference instruction, there will be memory reference instructions. So we will see some of the memory. So the table shows the memory reference instructions here. So these are the symbols. So in the symbol, in the memory reference instruction, we have AND, add operation, load accumulator, then store accumulator, then so all these operations are there, right? So we'll see this one by one. So these are the decode operations. So if like from D0 to D6 here, right? So AND operation means so the accumulator value will be ANDed with the address register which is stored in the memory. So this operation, this is a symbolic description of the AND operation at the decode operation D0. It is represented by the decoder operation D0. So this, if you write this instruction, it will do the AND operation, right? So then next is the add operation. So the content of the accumulator is added with the address register value which is stored in the memory location. Okay, so if you write MAR in the sense, there is an address register which is stored in some particular memory location. So that value will be added with the accumulator, that is add operation. Then this operation will represent the load accumulator here, right? So if we so the value of the accumulator which is stored in the memory will be loaded into the accumulator. So at the decoder operation type D2. Okay, then if you write STA, then it will store accumulator. So it will store the accumulator value into the address memory in the address register. So if you write this one at the decoder operation, the content of the address will be moved into the program counter. So then at the D5 decode operation, so that the program counter will be value is loaded into the memory in that address register which is stored in some particular memory location, and the program counter value will be incremented by 1. Okay, so this is ISZ operation, that is the content of the memory location is incremented by 1 and the content will be stored here. Okay, so the effective address of the instruction in the AR was placed so during the time T2 when I not equal to 0 and during the T3 when I equal to 1. So the execution of MR instruction starts with the T4 cycle here, right? So these are some of the memory reference instructions. So we have seen the two types of instructions here, that is register reference instructions and memory reference instructions in the instruction cycle of computer system. Okay, so whatever the operations we have seen, so when you are writing the assembly language code, so we'll be writing like this and to accumulator in the sense, so the value will be it will be written like this dr m the AR. So this will represent the read operand value. So then if you want to AND with the accumulator, then it will be written like this AND. Okay, let us say if you are adding add to accumulator, so the first the value will be read, then the content will be added. Then load accumulator. So how will be writing? So these are the standard mnemonics we have to write when you are writing and program in the assembly language. So let us say if you want to load an accumulator, so how to write it? So the content of memory is moved into the DR, then the value will be loaded into the memory. That is the accumulator value will be the mode. So how store accumulator is done? So by writing this instruction ACMR means, so the value of the accumulator is stored in the memory. Okay, so the same thing like the BSA, how instructions are written, whatever we have discussed. So they will use the next instruction to be executed here. Let us say branch instructions here. BUN means here in this instruction here BUN means branch unconditionally. So the unconditionally the branch instruction will be executed here. So the program counter will load the next instruction to be executed, and it will jump to the BUN. That is, it will go to the branch without any condition at 135 this memory location. Okay, so here again it will shows like after execution. This is before execution. So after execution, the if you write BUN program counter means that it will jump to that branch unconditionally without any condition at this memory location. That is to into that subroutine. Okay, so here you can see this address 136 and here 136. So if you write BUN means branch unconditionally, it will jump to that branch unconditionally. Okay, so this is the operation for DS4 and increment and skip if 0. So the ISZ means increment and skip 0. So this first will increment the value by 1, the data register value by 1, and then if it will skip if the value is 0, and the program counter value will be incremented by 1. Right, so whatever we have discussed till this in the table, the different types of memory reference instructions, so these all are described in the table. The different types of instructions, that is memory reference instructions, you have to remember that is an AND operation. So this is the instruction for AND operation, then this is the instruction for add operation, this is the instruction for load operation, this is the instruction for store accumulator, then this is the instruction for branch unconditionally, then increment and skip 0 if it is, and branch if the value of S is accumulator is 0. So this is these are the different table. This diagram shows the 7 different types of memory reference instructions. Okay, so this is that's all for the today's presentation. So in this so in the today's lecture we have discussed the instruction cycle. So what are the different steps included in the instruction cycle? And the different types of the data memory instructions and memory reference instructions. So these are some references we have included. That is Maris Meno, the computer system architecture, that is PhD third edition, and Patterson Hensey, the book name is The Computer Organization and Design, Hardware Software Interface, by the Morgan Kaufman, that is the 5th edition of 2013. So that's all for the today's presentation. In the next video, we'll be talking about the data representation. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.